Let us look at this problem called find the maximum GCD of the siblings of a binary tree. It's marked as easy. Essentially, it combines just normal tree traversal with math. So it just combines these two things. We are given a binary tree. Task is to find the maximum GCD of the siblings of this tree. We have to return the value of the node whose two immediate children has the maximum GCD. If there are multiple such nodes, we return the node which has the maximum value. Siblings are just the nodes with the same parent, and GCD, as we know, is the largest positive integer that divides both numbers without a remainder. There are a few things to note here. Return 0 if input tree is empty, that is level of tree is -1. Fair enough. Consider those nodes which have a sibling. Okay. Return 0 if no such pair of siblings found. That means if a node only has a left child but does not have a right child, then that left child is of no value to me. Okay. Both the left child and right child has to be there, and then I have to find their GCD. All right. So let's look at this example. So 5 and 2, their GCD is 1. So that's one option. 3 and 1's GCD is also 1. So between 2 and 4, any of them can be chosen. 4 is a bigger one. But 6 and 12, the GCD is 6. So that is the maximum GCD. And the root value is 3. So we return 3. In this case, when you look at 5 and 3, its GCD is 1. So we consider that. 9 and 6 GCD is 6. 9 and 6 GCD will be 3. 4 and 8, the GCD is 4. So maximum GCD we found everywhere among the pairs was 4, and the root for that is 5. So we return 5. And that's the thing. So tree traversal is easy. And how do we find the GCD? Well, for finding the GCD, we can use the normal algorithm where uh, the Euclidean algorithm that does the repeated percentiles or repeated divisions. So let's try all of that out. So, all right, let me make a full screen here. So let's first do the math bit, or let's first do the tree bit, right? So for the tree bit, essentially we just try to find out, uh, let's maintain some global variables for ease. So let's maintain max GCD value and also maintain corresponding to that max GCD value, what is the root, right? And let's initialize both of them to 0. I think in the problem it's given that your minimum values uh, will be at least 1. So if it was not, then we would have probably assigned these to some minus negative value, but that's fine. And now let's do the tree traversal, right? So okay, so we do, let's say, traverse root. Let's do pre-order traversal. Any traversal should be fine. So void traverse node root. If root is null, then just terminate. Otherwise, traverse root dot left and traverse root dot right. And before or after doesn't really matter. Let's now look at if I am a root node, then do I have two valid nodes? Do I get a pair of siblings? So if root dot left is not equals to null and root dot right is not equals to null, then I'm interested in finding their GCD, right? So let's say there is some function that calculates the GCD for now. So calculate GCD, and we pass in the value. So root dot left dot data and root dot right dot data. And if this GCD is greater than the max GCD root, sorry, max GCD value, then what are we gonna do? Then we're gonna update the max GCD value to this GCD value, and the max GCD root will be updated to this root node, right? So root dot val. There is one also case that we need to handle, which is if the GCD value is exactly equal to the previously calculated max GCD value. Like we are told, if there are multiple such nodes with the max GCD value, then we have to take the root which has the maximum value. So then we have to update the max GCD root to either whatever its previous value was or the current GCD root value, right? So max GCD root and this. Now that's the bit about the tree traversal and maintaining this. So when after we traverse at the end, we will return the max GCD root. All that is good. Initialized to 0. So if we don't find anything, we'll return 0, which is what the problem also asks us to do. So that's fine. Now let's do this bit of calculate GCD, right? So x into y. So the way to calculate GCD using the Euclidean algorithm of repeated division is while your y is not equals to 0. So if your y is 0, right? If your y is 0, you return x. So GCD of something and 0 is something, right? So that's one thing. And otherwise, what you do is, let me give an example to illustrate. So let's say we're trying to calculate GCD of 6 and 9. Fair enough. So, or rather, I will write it as 9 and 6 first. So if let's say we're trying to calculate the GCD of 9 and 6, we'll change it to this is equal to the GCD of you take the smaller guy 6, and when you divide 6 by when you divide 9 by 6, whatever remainder you get, so 9 percentile 6, which is 3, it's same as 6 and 3. And now again you do so. Basically, what I'm trying to say is at any point, GCD of x comma y is equals to GCD of y comma x percentile y. That's what I'm trying to do. So from 9 and 6, I take the smaller guy, and whatever remainder I get is I take in, and then similarly, so for 3 and 6, you can see you take 3 and 6 percentile 3 is 0. There is no remainder. And when you were y is 0, x is your GCD, right? That's the logic. So we build this logic. Now, you might think you have for this to work that x has to be greater than y. Even that is not true. Like it will just take one extra iteration. So for example, let's say if you started with 6 comma 9, and if you apply this formula, what this would lead to is GCD y will come here, and when you do 6 percentile 9, it is 6, right? So the swapping bit that you want to do, like which is you want x greater than y, that will automatically happen in the first iteration if it wasn't the case, if you just follow this formula. So we just have to do while y is not equals to 0. I want to try, let's say, a new x I will take as y, and a new y I will take as x percentile y. So let's update the x and y. So x equals to new x and y equals to new y, right? And eventually when y becomes 0, we return x. So that's our formula for calculating GCD. So that's the entire code. Let us try and run it to see whether there are compilation errors and fix those. Okay, we do have a few compilation errors. So we used root.val in our code. That's because of using another site which gives your data structure in that format. In this case, you have to use root.data. So let us update that. So we use root.val here. We'll change it to root.data and data, and I think everywhere else is fine. So let's try and run again and fix any more errors. Okay, this time we did not get any error. Let's submit and see whether all test cases pass or not. And they all test cases pass. So that's the typical way. There are other ways as well of finding the GCD where you could do repeated subtraction, or you could always just try all the numbers from the 1 to the smallest number and try and see which of them, try and find the maximum value, maximum much which divides both of them. But the most optimal or the most commonly used one is this method that we use, which does repeated division, because it reduces the time complexity to log of the minimum value. All right, that's it.